Hello, you're welcome to this lesson. In this video, you are going to learn how to use Gaussian elimination to solve systems of linear equations. So, if you have a matrix of the form Ax equals b, okay, we can augment this matrix into this form, and then after augmenting it, we perform a sequence of row operations, giving us one interchange any two rows to multiply a row by a non-zero constant, and then the third one add a multiple of one row to another. Okay, so I have an example here. We have this system of linear equations, okay, which we can write in a matrix form as Ax equals b, right? So all you will have to do is to augment A and then B. So I have the augmented matrix here, okay. So I'm going to perform the row operation so that we change this matrix to uh, an upper triangular matrix, okay, so that we use back substitution to solve it. You can also change it to a lower triangular matrix that I use forward substitution, okay, but in this case I'll change this into an upper triangular matrix. Okay, so because I want to change this to an upper triangular matrix, that means that I want these values or these entries to become 0, right? So let's look at how you are going to use these operations to change these values to 0. Okay, so now the first operation I'll do is that I would like to make this 3 0, okay. So what I'll do is that I'll say that row 2, okay, should be equal to row 2, okay, plus minus 3 multiplying row 1, okay. I'm using the third row operation, which says that we can add a multiple of one row to another, okay. So I'm adding a multiple of row 1 towards row 2, okay, but I want to get 0 here, okay. I want to get 0 here, so what I'll do is that I'll just negate this multiple. So instead of 3, I'll make it negative 3, so that when I add it to row 2, we can get 0 for the first entry in row 2. So let's do this operation and see what you are going to get. Okay, so I'll write down the matrix, okay, with row 1, okay, entries, okay. And then for the row 2, I will leave it for now. Before when you get the row 2, then you write the row 3. Okay, alright, so now let's look at how you're going to get the new row 2 values. Okay, let me just name this as row 2 star, okay, because that's the new row 2. Okay, so let's look at what you are going to do. So we are saying that the new row 2 should be equal to what? Row 2 plus minus 3 multiplying what? Row 1, right? Which you all know that we are using the third row operation. Okay, so let's look at what you are going to do. So for the first entry for the new row 2, okay, for the first entry for the new row 2, you are going to have 3, okay, plus, okay, minus 3 multiplying the first element for row 1, which will be what? 1, right? So when you simplify this, you're going to get 3 minus 3, which will be 0. So the first entry for the new row will be 0. Let's do the second entry. So that one you're going to have 2, okay, plus minus 3 multiplying this one here, okay, multiplying 1. So let's simplify that. You're going to have 2 minus 3. That gives us a value of minus 1. So the next entry is minus 1. And then let's look at the last one. Sorry, that's not the last one. We have 1 plus minus 3, okay, multiplying 2, right? Okay, so we are going to have 1 minus 6, which will give us what? Minus 5. So then bring the minus 5, and then the right hand side value, okay, we have 8 plus minus 3 multiplying 5. So that will be equal to 8 minus 15. That will give us a value of what? Minus 7. So you have minus 7 here. So that becomes our new row 2 entry. So you are going to have 0 minus 1 minus 5 minus 7. Okay, alright. So now what I want to do is that I want to change this value here also to 0. Okay, I want to change that one there also to 0. So let's look at what you are going to do. Alright, so let's look at the operations and look at which one we can apply here. Okay, so you see that I have one here and then I have one here. Okay, so if I subtract 1 from 1, I'm going to get 0, right? So what I'll do is that I'll multiply row 1 by minus 1, and then I'll subtract it from row 3. So we're going to have our new row 3. Okay, we're going to have our new row 3 to be equal to row 3, okay, plus, okay, minus 1 multiplying with row 1, right? We are still using the third row operation. Okay, so let's go ahead and look at the entries. Okay, so let's look at the first entry. We say that row 3, okay, should be equal to what? Minus, should be equal to, the new row 3 should be equal to the old row 3 plus minus 1 multiplying row 1. Okay, so for the first entry, okay, you're going to have 1 plus, okay, minus 1 multiplying 1. This will give us 1 minus 1, which will be 0. So we have our first entry to be 0. And for the second one also, we have minus 2, okay, plus minus 1 multiplying 1. This will give us minus 2 minus 1, which will be equal to minus 3. So the second entry is minus 3. And then for the third entry, we are going to have 3 plus minus 1 multiplying 2. Okay, this will be equal to 3 minus 2. And that gives us a value of 41. And for the last entry, we have 0 plus minus 1. Okay, multiplying 5. Okay, so this will give us a value of what? Minus 5. So we're going to have 1 and then minus 5. Okay, so this will be our matrix now. We're going to have 0 minus 3, 1 minus 5. Okay, so now the last thing we'll have to do is to change this minus 3 here to 0, okay, so that you will get our upper triangular matrix. So let's look at how we are going to do this. Okay, so to change this 3 here to 0, okay, what I'll do is that I will multiply row 2, okay, by minus 3, okay. I'll multiply row 2 by minus 3, then I'll add it to row 3, okay. So you're going to have row 3 star star, okay, to be equal to row 3 star, okay, plus, okay, minus 3 multiplying row 1. Okay, so when I do it this way, we can make this value 0, okay. So let's look at that. Okay, so let's look at the first value. Okay, so I have row 3 star star. Let's look at the entries. Okay, let me free up some space, then we continue. Okay, so for the first entry, you're going to have 0, okay, plus uh, minus 3, okay, multiplying 0, right, which will give us 0. So we have 0 here. And then the second one, we're going to have minus 3, okay, plus minus 3 multiplying minus 1. That will give us a value of minus 3 plus 3. And this will be equal to 0. So we get the second entry to also be 0. And then the third one, we're going to have 1 plus minus 3, okay, multiplying minus 5, right? So let's see this. You're going to have 1 plus 15, which will give us a value of what? 16. So we will have 16 here. And then for the last entry, we're going to have minus 5, okay, plus minus 3, okay, multiplying minus 7. Okay, so let's see. We're going to have minus 3 times minus 7. That gives us a what? A value of 21. So we're going to have minus 5 plus 21. Minus 5 plus 21. That gives us a value of what? 16. So the last entry was would be what? 16. Okay, so now let's rewrite the matrix again and then see what we have now. Okay, so if I rewrite this matrix, okay, we're going to have 1, 1, 2, 5, okay, and then we're going to have 0 minus 1 minus 5 minus 7. Then we will have 0 0 16 16. Okay, so this is our upper triangular matrix now. So now we can use back substitution. You can use back substitution to solve for the variables x1, x2, and then x3. So from here, we're going to have the first equation to be 16 x3, okay, will be equal to what? 16, right? And then this will give us x3, okay, to be equal to 1. And then the second equation will be minus x2 minus 5 x3, okay, to be equal to minus 7. We're going to have minus x2 to be equal to minus 7 plus 5 multiplying x3, which is what? 1. So we're going to have minus x2 to be equal to minus 7 plus 5. So we're going to get minus x2 to be equal to minus 2, which will give us x2 to be equal to 2. So now let's find x1. So for x1, you're going to have x1 plus x2, okay, plus 2x3, and then this will be equal to 5, right? So you're going to have x1 to be equal to 5 minus x2 minus 2x3, okay. So let's see what you're going to get. You're going to have 5 minus 2 multiplying 1. So you're going to have 5 minus 4, which will give us x1 to be equal to 1. So then we are going to have x1 to be equal to 1, x2 to be equal to 2, and then s3 to be equal to 1. So these are to use Gaussian elimination to solve system of what? Linear equations. Just like I changed this to an upper triangular matrix, you can also use the same operations to change it to um, a lower triangular matrix, okay. Then use forward substitution to find the variables.